Hello, today my team and I would like to present about sprinkle system for agriculture. So my team member consists of Abdul Razaq bin Abdul Hamid, Ahmad Rifqie bin Ahmad Fikri, Muhammad Hanis Izwan bin Kamalrulzaman, and me myself, Muhammad Azril Hakimi. Okay, so the first is the background of this project. The purpose of this project is to provide water to plants at the right time and amount, and also diverts water from sources to specific fields or plants. So we came up with a solution. We make agriculture irrigation system. So the challenges that we found in making this project is that farmers struggles due to irregular work schedule and negligence. They also have a major land to cover. So due to human errors, um, we will miss some spots. And also, farmers forget to turn off water pumps, causing wastage. Forgetting to turn on irrigation also leads to plant damage and a busy lifestyle to make it difficult to manage manual watering. So in this project, we'll utilize a soil moisture sensor to detect moisture level in the soil, whether it's dry or wet. The moisture sensor is then connected to an Arduino microcontroller, which will work by simulating on Proteus software and then activating the DC motor through an op-amp that compares the moisture content of the soil to a reference value, which will activate the pump through a relay. The second is the problem statement. Issues with the traditional method is no focus on water conservation. That means we waste water and the higher bill for farmers to pay. And soil moisture fluctuations stress plants and affect their growth. So we can say that soil moisture, the more drier the plant, the more less the we can say soil moisture fluctuations stress plants and affect their growth. So when the soil moisture uh, is not consistent, it can affect their yield and make their yield more less and also not expected as we want to. The third one is the lack of automated control leads to an inefficient water use. That means more wastage of water. The fourth one is population growth exacerbates water and economic challenges. Population growth, as we can tell, the more people that is on this planet, that means we will use more resources and we need more resources to consume. So the modern challenges that we face today is that a busy lifestyle prevents people from watering plants regularly. For example, people are working from 9 to 5. They don't have that much time uh, to take care and manage their schedule to water the plant. Travels or vacation make it hard to care for plants. When we travel, we don't have people to supervise for the plants. And the third one is global water scarcity poses a major challenges, especially in countries with limited resources. For example, in Africa, they don't have that much water to use in their country. So they need efficiency in controlling their water amount that they spend in their crop. And the objective for this project is that we are capable of developing agricultural irrigating system. This objective we can use by a sensor. We can achieve by sensors to monitor soil moisture levels, temperature, or other relevant environmental factors. And we also can achieve this by controllers to process the sensor data and make decisions on irrigation timing and duration, and also control the flow of water. Also, we can use actuators to control the opening and closing of valves, the operation of pumps, and other irrigation equipment. And lastly, the software. To implement the control, logic, manage data, and potentially provide a user interface for monitoring and control. By doing this, all of the above, we are capable of developing an agricultural irrigation system. The second objective is by using the EZ68K microprocessor expertise to construct the program code. This objective emphasizes the use of the EZ68K microprocessor and its associated development environment to create the software component of the irrigation system. This would involve learning and applying the instruction set and assembly language of the 68K microprocessor, also developing algorithm for data acquisition, processing, and control. The third one is writing and debugging assembly language code for the 68K microprocessor. The third objective is in order to use this EZ68K software to mimic the program code. This objective highlight the use of simulation tools to test and verify the program code before deploying it on the actual hardware. This would involve utilizing the EZ68K software's simulation capabilities to create a virtual environment for the 68K microprocessor. Second one is running the developed code within the simulator to observe its behavior and identify any errors or unexpected result. Next one is debugging and refining the code based on the simulation result. And also we ensure that the simulated behavior accurately reflects the expected behavior of the system in the real world. The next one is the project scope. The project scope is the program only suitable to water up to 7 plants, as we only use 7 switches and 7 sensors to help irrigate the plants. The second project scope is the watering process is only for a specified time. Thus, a bigger plant might not receive enough water as we set only 1 second of watering in our system. And also the system need to be manually turned off as we use a toggle switch.
Okay, for the next part is methodology. And the program software that we use is Easy68K and WorkPi. For Easy68K, it's normally used for a program and assembly 68K program. So for the next, so it's quite suitable for us and enable to running our 68K program, utilized to code an agriculture sprinkler system. And for the next is a display hardware view of the 7-segment display. So 68K is our main software that we use in this project. And for WorkWe is a web-based Arduino emulator for designing, building, and testing project with the hardware. And normally WorkWe is support microcontroller like Arduino Uno, Mega, and ESP32, along with virtual component like motor, LED, and sensor, which is good for us to use at the hardware version. With its code editor and real-time debugging, WorkWe is ideal for beginning and educator and users. Okay, next is our list of components. So basically we had used 6 components, and first of all is toggle, a mechanical switch used to manual turn a circuit on or off. Okay, next is a battery, an energy storage device, provide power to electronic device. A 7-segment display, LED, sensor, and battery. This one is a battery, a set of 8 1.5 battery to power the whole system and Arduino Uno. Okay, here is a system flowchart. For a system flowchart, there are divided by 2. For the flowchart appear complex due to a detailed steps. After starting, there is a 2 condition are checked. If any switch 1 to 7 is off, LED 1 turn on for 1 second, watering plan 1. If all switches are on, the system skip to the next active switch. So here you can see the flow of the system flowchart. Okay, next is system description. For system description, they also divide by 2, either the switch on or off. When a toggle switch 0 to a logic 1, if a switch 1 to 7 is off, there is watering. But when switch 1 to 7 is on, there is no watering. Starting the watering process, switch 0 must be in the 1 on state initiate the water process for all the plant. Skipping the process, if any other switch is in the on state, the watering process will be skipped. Okay, and here is a schematic diagram. So now we use WorkWe software to emulate a real-world agriculture sprinkler system. The system also use 5 plus volt power and a ground for the decoder and 7-segment display. Switch and LED act as a sensor, toggling logic state to display number 0 to 7. The display light up based on the number of a switch turn on.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rifqie bin Fikri. And today I want to discuss about result and discussion. Next. For the IDE 68K simulation, I use that already have 3 scenarios. So for the scenario 1, as you can see, when I hit the switch button of 0, the LED will display about LED will turn on from LED 1 until LED 7. So as you can see, for the LED 0 is indicate the system is on or not, while the rest of LED is indicate the system is running. Okay, so you can see now. When I change the value of delay, as you can see, the number of looping is very slow. Okay. Next is scenario 2. For the scenario 2, set up the IDE system for user switch, LED, and 7-segment for the display. So when I run and I turn on the switch, and then let's say if I want to switch on 3 and 5, so the number display at 7-segment is 3 and 5. Also, I tried another switch. As you can see, the display will continue display that the button that I show. So this is for to like quarter water that continue which side or which number you want to use. So for the scenario 3, I use slider as a sensor. So slider indicate which sensor that will on or will off. So for the switch 0 is for the turn on the system, and the switch 1 is for the light to get through to all the plant. If let's say the slider move to the which LED indicates, so the 7 segment will display which LED that's on, and power and switch one button for the to open or close quarter sparkle. So next is I use hardware based on workweek application that I do at in the website, because the website also provide the Arduino and other things that I want to use. So as you can see, for the scenario 1, when I start the simulation, basically the hardware itself, when I press the button, it's same as like IDE 68K program. So it should continue running from LED 1 until LED 7. Next is I use hardware based on workweek application that I do at in the website, because the website also provide the Arduino and other things that I want to use. So as you can see, for the scenario 1, when I start the simulation, basically the hardware itself, when I press the button, it's same as like IDE 68K program. So it should continue running from LED 1 until LED 7. For the case of scenario 2, when I start the simulation, I need to press first for the system button, and then I just press two button that to turn on. So it's like which button that I want, or which the place that I want to pour a water or sparkle water, like that lah. So as you can see, if I press number 2 and 7, it will light on 2 and 7 and pour water, sparkle water on that. Okay, for the scenario 3, it's more like using a sensor itself. So for the simulation scenario 3, the button itself is more like sensor itself. So when trigger the button, so the LED will turn on and will display at 7 segment.
Okay, now I will discuss our methodology or simulation. Okay, so we start by LED and initial setup. Toggling switch 0 to logic state 0 to illuminate LED 0. The LED 0 acts as a light sensor in a practical applications. This program only execute when light is detected or switch 0 is manually triggered. So here, then we get the system operation. By triggering switch 0 to logic state 1, will start the system. So the LED in the 7 segment will display illuminate one at a time, from LED 1 to LED 7. LED 1 to 7 will represent specific vegetable. As you can see, LED 1 for carrot, 2 for spinach, 3 celery, 4 beets, 5 cauliflower, 6 broccoli, 7 eggplant. So the 7 segment display show digits 0 to 7. Digit 0 for time reset, while digit 1 to 7 correspond to sprinkler for each vegetable, progressing one vegetable to the next vegetable. Then we have also a selective watering. Setting switches 4 and 6 to 0 waters only the corresponding vegetable. The other vegetables are skipped to simplify the consumer task. And then we got the reset and delay feature. Toggle switch 0 to 0, reset or halt program. Delay subroutine, and we got delay 1, which is the pauses between vegetable and turn off the current LED. And we got delay subroutine 2, which is to postpone timer reset before the next cycle begins. Then we get a branching logic. Conditional branch BHI used for the logic state high 1 to progress to the next vegetable. Hi, my name is Razaq bin Hamid, and I will continue by explaining the conclusion and recommendation. So to conclude our project, the 68K Visual Simulator is a powerful microprocessor for building system that can enhance lives. It helps to integrate the knowledge to create practical, efficient, and life-simplifying system. By developing a sprinkler system for agriculture, it helps to address the varying water needs of different plants. Beneficial that you can get for this system is very good for farmers and individuals, gardeners, to managing multiple plants. Like if you're a farmer or gardener, you want to manage a lot of different type of plants daily. By using this system, is very and the 68K Visual Simulator, although it's a small part of the microprocessor world, the foster creativity and innovation for advanced technology is very good. And then we would like to recommend some to improve for our system in the future. For example, first, by adding soil moisture sensor. It can detect if plants are receiving enough water. It is to prevent plant from withering by monitoring soil moisture. It helps to determine the precise or average water required by plants of varying size. Like if you, a gardener, you need a specific plant or that require specific water liter that you need soil. So it's not like very essential for the irrigation system, but it's very crucial for your healthy plant growth. Second is we like to recommend time integration. It helps to enhance system functionality, performance, and quality. If you want to edit something in integration, it can help your system improve sequentially. And then automates the irrigation process. Plus, it can reduce farmer workload. Like if you need a lot of worker to manage your plants or farm, by integrating this system, it can reduce your workforce. And then it allows plants to be watered automatically at specific time interval, like you need a specific time, specific hours that need to be watered regularly. So by implementing this system, the time intervention in the system, it can help to improve the efficiency of the system. And then lastly, the integration can use a timer to simplify and improve the watering process. So I think that's all from us. Thank you very much.